Hello guys, welcome back to the series of tutorials on C++. I am Deepak Niyal, and in this tutorial I am going to talk about various types of polymorphism. So let's start. So polymorphism is basically of two types. One is compile time and another is runtime. So when we talk about compile time, there are basically two types. One is function overloading, and we have already studied it. This is the way you can achieve polymorphism, compile time polymorphism in one way, and another is operator overloading. And this thing we have covered in our previous tutorials. Then if you talk about runtime polymorphism, it's basically function overriding, which we have seen in previous lecture, but it can be achieved through virtual functions, and we are going to study virtual function in our coming tutorials, right? So this thing basically occurs when derived class has a definition of one of the member function of the base class, right? So to understand all these things, we should talk about one important concept. So what does it mean? With public inheritance, an object of a derived class can be treated as an object of its base class also. So let's take an example so that we can understand this thing in an easy way. Suppose you have a shape class and it has an object which is triangle. So we can say that every triangle is a shape, but we cannot say that shape is a triangle, right? So this thing is perfectly allowed, but this thing you cannot say. So this means an object of a derived class, like triangle in our case, can be treated as an object of its base class also. So we can say that this is shape. But reverse is not true. We cannot say that every shape is a triangle. Clear? So this is the concept you should remember, and we are going to use it in further discussion. So let's move forward and discuss it more. So we have a shape class, and suppose its object is sh, and for the triangle our object is tr. In next lecture we'll create a program of this and understand it using implementation, but as of now you should understand the concept only. So we have these two classes and we are having these two objects, and both the classes have a function draw. So basically draw is in shape, but all its derived classes implement this function, or we can say override this function draw in their own way, and we are just taking one class here, that is triangle. So let's try to call this draw function in multiple ways. So we have a triangle and we created its object tr, or to make it simpler let's take it just t and make it s only. So it's s and it's t. Then for the triangle class we have t object, and we can call t dot draw, and it's going to draw a triangle for us. And you can understand that this is derived class object, right? Now other than this, what can we do? We can create object of shape like this, and if you call s dot draw, it's going to call function of base class because it is object of base class. Clear? So this is clear to you. We have already done this thing. Now moving a bit ahead, let's create some pointers. So for triangle class, we are creating a pointer and we can call it tptr. It's derived class pointer. And if you try to access draw function using this, you have to use tptr, then use arrow here and draw function, and this is going to call triangle function and it's going to draw triangle. So we have seen three ways till now, so keep understanding these things. Now coming to fourth part, you can also create shape ptr, which is shape and star sptr. This is basically base class pointer, and then if you want to call draw on this, you have to use sptr and draw, and this is going to call draw function on base class. So whatever is its implementation, it will print or draw that kind of thing. Basically we don't have any thing that is shape, but we can just print a message there. This is base shape, right? So we can do something like that. Now coming to our most important things that we are going to discuss now. So first thing is we have to aim our base class pointer at the base class object. So how we are going to do that? So we have shape ptr and just assign it address of shape object, which is here. So this is perfectly fine. And if you want to call draw on this, you have to just use like this and it will work perfectly. There is no issue in that. Clear? Now try doing something else. And what we are trying to do, we are aiming derived class pointer at derived class object, right? So how we are going to do that? We'll create a pointer, or this pointer is already created, but we'll assign just address of object t here, and then we can call draw function using this pointer, and this is going to draw this depending on the functionality what we have implemented in that draw function. And now the most important thing is coming now. We are aiming base class pointer at derived class object. So why this is important you will understand now. We have a shape pointer sptr and we are going to assign address of triangle in it, right? And then we are going to call sptr and draw. So our aim doing this is we want to call draw of this T or triangle using this pointer. As we have learned the concept here, you can see that with public inheritance, an object of derived class can be treated as an object of its base class also, right? So we are going to implement that thing and we expect that it will print this. Clear? But running on this program, you will find out that it is not drawing triangle. It is just printing the message that we have seen here. This is base shape. So we know the concept that each triangle object is an object of shape also. But now we were trying to point this draw or draw of this triangle, but it is doing something else. Can you think a bit and tell me the reason why this is happening? Why base class draw is invoked? So if you have got an answer for this, that is fine. Otherwise, we are going to discuss that. So if you look at this, it is revealing that invoked functionality, this functionality depends on the type of the pointer or the reference used to invoke the function. So the pointer here is sptr, which is pointer of base class. So it means that the invoked functionality depends on the type of pointer or reference, right? That was used to invoke the function, not the type of the object for which function is called. So this is the type of object for which you want to call the function. But it is possible to invoke the object type functionality rather than invoke the handle type functionality. And that concept is virtual function, right? So we have to use this concept using which we can call or we can invoke the functionality of this object. Clear? But we are going to cover this thing in next tutorial along with this program that we have seen till now. We have just seen its idea how this program will work or how this program will look like. But in next tutorial we are going to discuss this in very detail. We'll implement the program and we'll discuss how this virtual function is going to help us, right? So I think this is enough for this lecture. If you have any doubt or query regarding any of this, you can just write in the comments and I will try to respond back as soon as possible. So guys, see you in the next video with some new concept. Till then, thank you so much.